All right, so today we are going to do slope fields. A slope field is a representation of the general solutions of a differential equation. Which is actually kind of cool because the general solution is an infinite number of answers. And so you're drawing a visual representation of an infinite number of graphs. That's kind of neat that you can do that. It's cool. It's cool, guys. You kind of have to trust the process with these. They don't look great to start out with. Also, if you are very type A and like this needs to be perfect, you're going to need to take a few deep breaths because it isn't going to be perfect. It's going to be good enough. Okay. You have to go with it. Now, if your differential equation only has X's or Y's, you kind of catch a break because you can knock out whole rows or columns at the same time. If you only have X's, all of your columns are the same. And if you only have Y's, then all of your rows are the same. So it makes it easier to draw. So I made the first two, one of them only X and one of them only Y, so you can see what I'm talking about. When it's a mixture of X and Y, you kind of have to go point by point, and it's a little tedious. Not difficult, just tedious, okay? So you gotta take a few deep breaths and trust the process. Bless you. Here's all the things we're gonna do for these. We're gonna draw the slope field, describe what they look like, all right? Not like a paragraph of information, but just a short description. We'll solve for the general solution. So this is more quiz review. We'll solve for the particular solution. So more quiz review. And then what they ask you to do sometimes in the AP exam is draw in the particular solution. Because remember how I said it's an infinite number of answers? They might ask you to draw in that one particular one, okay? So looking at this, and you've got all these little dots here. It looks like the dot game. Do you know what I'm talking about? Where you play with a friend and you draw in the thing to put, yeah, the little dot game. Anyway, it's not that. Don't do that. But do you see how this only has X in it? You can knock out whole columns at the same time. All the columns are going to be the same, which is really kind of nice because it doesn't matter what Y is. And once again, dy dx means derivative and derivative means slope. So that's why it's called a slope field. All right. So let's do this first column. What is the X number for every single one of these points? -2 for all of them, right? If you plug in -2 for X right here, what do you get? 3. You should have a slope of 3 for all of these. I don't know, about like that much. Again, I told you it wasn't going to be perfect. But 3 is a positive number, so you want a little slope that's headed upwards, like a little segment that has a slope of 3. With me? You're like, no. Again, you got to trust the process. You'll see what I mean once we get a whole picture. Can you put that phone away? For this column, what is the X number for every single one of the points? -1. If you plug -1 in there, what do you get? 2. It just needs to be a little less steep than 3. Do you get what I'm saying? Just in relation to each other, they need to make sense. So something that's like a little bit less steep than the ones we just did. All right, how about the next column? What is X for all of these points? 0. If you plug in 0 for X, what do you get? 1. This was 3, this was 2. So 1, again, just in relation to each other, they need to make sense. So something that's, do you see how they're going less and less steep? Okay. What is X for the next column? 1. At all these points, X is 1. If you plug in 1, what do you get? Now that one you can do perfectly because 0 is horizontal. So all of these will have a 0 slope. And then what's going to be our slope for the last one? -1. So it should be a reflection of the positive ones that you did. Make it be something like this. So again, what you drew is a representation of an infinite number of graphs, which is kind of cool. Get on board with that because that part's sort of neat. They're not that fun to draw, but that part's cool. So let's describe them. If you were to draw in graphs following these slopes, what would they look like? If you drew one in. And don't overthink it, guys. If you just drew something and follow on along with these. A parabola that is upside down, a reflected one. All right, they are reflected parabolas. Plural parabolas. It's an infinite number of parabolas. That's kind of cool. Kind of neat. You just drew an infinite number of graphs. All right, so we described it. Now we're going to solve for the general solution. You're going to multiply the dx over, I like to put a 1 in front of the dy if it gets left by itself. I just find that that helps people. And then do your antiderivatives. So what are your antiderivatives going to be? Yeah, this part will be y equals, which is nice because y is already by itself. And then this side will, I heard somebody say x minus 1/2 x squared plus c. Now, does that answer make sense with our drawing and our description? Why does it make sense? It's got a squared for the parabola and it's negative, so it's reflected. It's written in the other order, but you know, whatever. Okay. Now we're going to solve it for this specific initial condition. I made this first one pretty easy. If you plug in 0 for x and 1 for y, what is your c value? Is 1. I didn't make them all that easy, but that one was, you know, doing the first one, right? And then when you go to draw it in, all you have to do is start at the point they gave you, which in this case is 0, 1. So that's right here, 0, 1. And you're not allowed to go through any of the other slopes. So don't cross them. You just kind of like swim with the current. I know it's like such a crap explanation, but it's gonna like do something like this. Do you see what I'm saying? You're not allowed to like go through any of the other slopes. No touching, just like you follow along with the current. And the other thing that they grade, you know, particularly on these is your graph has to go all the way to the edges of the grid. So like, for example, if you stopped here and didn't draw this part in, like if you stopped there, they won't give it to you. Yeah, to be honest, they're actually pretty picky about these, which drives me crazy because it's like a, well, it's good enough kind of thing, but then they're really picky about it. It's like, you know, following along it was the trend of how College Board acts all the time. Okay. And I'm sorry, what was the rest of your question?
No, I said like arrows.
Oh, you don't need to draw arrows on the ends. It just needs to go all the way to the edge of the grid. When in doubt, make it go a little further than you would normally. Right? Yeah, like go off the graph just to make sure they'll give it to you. All right, let's try it again. Do you see that how this one just has y in it? So we're going to knock out whole rows at the same time. So for this first row, what is y for every single one of those points? 2. If you plug in 2 for y, x doesn't matter, what do you get? 1. All right, so we're going to have a slope of 1 for that whole row. Again, just kind of trust the problem. All right, what's going to be your slope for the next row? Look at what y is, plug it in. 1/2. So it just needs to be less steep than 1. Again, just like in relation to each other, they need to make sense. It's not going to be perfect, but like make 1/2 less steep than 1. All right, how about the next one? 0. Those are the only ones that you can really do like perfectly, are the 0 and the undefined. And then down here, it's actually going to be the exact same thing, except what? Yeah, opposite. You're just going to reflect those over. So this is going to be -1/2 and then -1. So you just drew an infinite number of graphs. Good job. You like that one better?
Yeah.
Some of them are pretty, some of them are not so much. Let's describe it. If you were to draw in a graph following along with those slopes, and again, don't overthink this, just what kind of function would it be? Like this one was quadratic.
Oh, exponential?
Exponential, good.
And we just gotta figure out the way it's going.
Yeah, so do you remember how the general solution is going to have a plus and a minus? That's because the plus can be up here and the minus can be down here. We drew an infinite number of them. And I would also go ahead and say there's a horizontal asymptote at y equals 0. If there's like an important part of the graph, like a characteristic like that, you want to mention that too. When I write HA, do you know what that means? A horizontal asymptote? Okay, I don't like to abbreviate to the point where no one knows what I'm talking about anymore. All All right, so let's go ahead and solve this. You would divide over the y. So since you're dividing it over, it would be 1 over y, which as a heads up, that antiderivative would be what? ln, and that's how e gets in there, and that's why it's exponential, just making the connections. All right, equals, and then what stayed on this side? Good, because this is in the denominator. So 1/2, and then you multiply over the dx. And this is all just more quiz review for you. We're just doing more quiz review, solving these. So this will be ln y equals 1/2 x, perfect, plus c. And then to get y by itself, you e. Do you remember e is a number and c is a number? So we just pull that out front as one big constant. And then the absolute value, bless you, is what gives you the plus minus. So it's c e to the power 1/2 x. And what I brought up last time, but I know it was over a week ago. Do you remember the PERT formula from pre-calc? It's that. That's what it is. It's just a c instead of a p. And then the 1/2 is your r. And then instead of time, it's x, bless you. Yeah. So anyway, PERT is what that is. So what we're going to do is go back to this step and plug in our initial conditions. So this is in general, this is the one particular one we're going to do. So we're going to plug in 2 for x and -1, excuse me, for y. So -1 absolute value is +1. And then what's ln of 1? 0. Equals, so again, -1, it changed to +1. ln of 1 is 0. And then what are we plugging in for x? 2. So 1/2 of 2, 1 plus c. So what is c? -1. Perfect. So we're going to recopy that line where I had the arrow. Sorry, I'll zoom out so you can see the whole thing. So we're going to recopy that line where I have the arrow. If you're like, why can't we jump to the end? You can't do that because you've done simplifying. You have to go back and do it again. I'm sorry. It's not that many steps. Recopy it, but put the -1 in there. And then you would do e to the power of that stuff. Now, instead of plus and minus, you have to make a decision. Why am I picking the negative version? You have to pick the initial condition is negative. And you'll see in the next step, when we draw that in, it's going to be on the negative side. Okay. So what point are we starting at? 2, -1. So 2, -1 is right here. And there's not really a whole lot to this one. It's going to coast along the asymptote and do something like that. But to make the connection, you can see that it's, negative on the underneath side. And this would obviously like keep going. Hanging in there? I know we're getting back in the swing of things from spring break. I think we can finish this before lunch. We'll see how it goes. Now, these will take a little bit longer because you can't do whole rows and whole columns at the same time. It's like womp womp. However, you can knock out a little bit of it. First, you want to find where it's not differentiable. And we'll do a review. What form is indeterminate? This is back from limits in unit 1. What meant indeterminate? Over 0. Remember 0 over 0? Good job. All right. What x and y numbers will give you 0 over 0? Y is -1 and x is 0. So at 0, -1, it should be blank. There should be nothing. But I'll tell you, here's what I do. I bold the point like that to remind myself I didn't forget to do it. It's just supposed to be left blank. Does that make sense? Because I know myself and I just would forget. Like I would be like, why did I put anything there? So that should be left blank. All right, then everywhere else that y is -1, what will your slope be? If y is -1, 0. So for all these points, you can go ahead and put in 0. And then when x is 0, you have a 0 denominator. So that means undefined. So all these points where x is 0, you get undefined. So you can knock out a few of them. But the rest of these, you have to plod along and do point by point. Okay, but you can, it's not that hard. Again, tedious, but not difficult. So let's do this first row. For this first row, y is 2 for all of them. Do you see what I'm saying? Okay, so if y is 2, 2 plus 1 is 3. Did that go through? Sorry, hold on. So the numerator is gonna be 3 for all these points. Just kind of hold that in your head. 2 plus 1 is 3. What is x for the first point? -2. So you'd have 3 over -2. That's -1.5. I don't know, like that. Again, you have to trust the process and it's just gonna be good enough. For this one, x is -1. So you'd have 3 over -1, which is -3. Now I just need for that to be steeper negatively than -1.5. Like just in relation to each other, they have to make sense. And then these, aren't they going to be the same thing, but the other way? Yeah, so this should be +3 and this would be, +1.5. So see, you won't take that one. You'll be all right. For this next row, y is 1 for all of them. 1 plus 1 is 2. So the numerator is 2 for all of these. So just kind of hold that number in your head. The numerator is going to be 2 for all of them. So for the first one, x is -2. 2 over -2 is -1. That should be a little less steep than -1.5. All right, and then this one would give you 2 over -1, so -2, that would be like maybe in betweenish these two, and then just reflect them over here. All right, for the next row, y is 0 for all of those. 0 plus 1 is 1, so the numerator is 1 for all of these. So if you plug in -2 for x, that would be -0.5, so they're getting like less steep here. And then this would be 1 over -1, which would be -1, and then reflect them this way. And then these, if you watch me point to this, are going to be the same as the row we just did, except reflected. Are you following me? I'm trying to save you some time from having to do every single one individually. You can take these ones and flip them the other way. This one looks cool. It looks like a firework or something. There, we did it. See, that wasn't so bad. All right, describing them. You're not differentiable at this point. Can you remember some reasons why a function would not be differentiable? There's a few, but there's one that usually people will remember. Not differentiable due to... Oh, an asymptote is one of them. Oh, you guys are remembering the less common ones. Good job. But what's this one? Not differentiable due to... Sharp edge. Okay, so what type of a graph? And we've had quadratic, we had exponential. What type of a graph is going to have that sharp edge? Absolute value. Good. So it's absolute value with the point at 0, -1. Absolute value with the point at 0, -1. But, sorry, my handwriting got weird, so I'm just rewriting that. It is an infinite number of absolute value graphs. Watch me point to this. You could have one here, or upside down here, or over here, widened out, and like, do you get what I'm saying? The only thing they have in common is that for all of them, the point is right there. Cool. It's cool. It's neat, guys. All right, let's go solve it. You would have to divide over the y plus 1. So it's going to be 1 over y plus 1 dy. You have to divide that to the other side. Equals, and then what's still on the right? Yep, good. Oh, perfect. 1 over x dx. So what is your antiderivative? ln y plus 1. There was no u substitution because the derivative of y plus 1 is just y plus 1. But extension question. Say it was a 2y plus 1. What adjustment number would you stick out front? Okay, good. You just throw the 1/2 out there. All right, equals ln of x plus c. And then to get rid of ln, e, remember e is a number and c is a number, so we're going to pull that out front. We're going to put plus and minus for the absolute value. It's e to the power ln absolute value of x. So what's going to happen to this e and ln? Yeah, those are going to cancel. And then what's your last step to get the y alone? -1. Good. So y equals plus and minus c absolute value of x -1. Pause there and let that sink in for you. I want you to make the connection. Do you get how this makes sense with this graph though? Because you could have it stretched or shrunk. Any number could go there, but do you see how the -1 brings it down 1 and that's where the point is? Are we connecting those? It does make sense. All right. Now we're going to do the particular one for this initial condition. So you're gonna go back to this step right here, right after you did the antiderivative. You can't jump to the end. It doesn't work. Just trust me, all right? We're gonna plug in -2 for X and 0 for Y. 0 plus 1 is 1, and then ln of 1 is 0. Good. So you get 0 equals ln absolute value -2. Well, that would just be ln of 2 plus C. So what is our C value? Negative ln, whatever that is. And so we're going to recopy that line. Again, you can't jump to the answer. It just doesn't work. Don't try to skip that. I let you skip steps all the time whenever it's applicable because I know the exam is timed. You can't skip those steps. You have to write it out. I know it's a lot of ln's, but they're all going to go away. When you do exponentiate, it's e to the power of, you're going to have y plus 1 equals. Do you see that subtraction there? That means you divide. Whenever you are multiplying, you add your exponents. Whenever you're dividing, you subtract your exponents. So it ends up being this because it's subtraction. You divide those things. It happened in pre-calc. I did teach you the log properties. It's just no one ever remembers them. It's fine. It's whatever. Last step would be subtract the 1. If you don't like how that's written, instead you can write 1/2 absolute value of X. Do you get what I'm saying? Like, does anyone like that better? Let me show you what I mean. You see what I'm saying there? All right, and then when you go to draw in the particular solution, you're going to start at -2, 0, which is this one. Now here you actually can go through some of the other points because each side of the absolute value is linear. So it's going to look like this. So it's an infinite number of absolute value graphs, but that's the one particular one that we got. And we will be able to finish this before lunch. Go us. All right, first let's find where we're not differentiable. So what would X and Y be to get 0 over 0? -1, 0, good. So just like bold that point. Technically, there should be nothing there. It should get left blank. I just know I will think I did something wrong if I don't do anything. So I just bold the point. All right, and then where can I put 0 slopes? Let's knock out the 0 and the undefined. Where are you going to have 0 slopes? Where X is -1. So where X is -1, you're going to get 0 slopes. So like that. And then where do you get undefined slopes? Where Y is 0. So you can knock out, a fair few of them. So let's try and do this first row. For that whole row, Y is 2. Don't go to sleep on me. We're almost there. Y is 2. If Y is 2, what is your denominator? Try and hold that in your head. For this entire first row, your denominator is 4. Okay? So for this point, X is -2. If you plug in -2 plus 1, -1, so -1/4. That's like a very shallow negative slope. For this one, X is 0. That would give you a +1/4. So like that. For this one, X is 1. That would give you 2/4 or 1/2. So like slightly steeper than 1/4. And then this one would give you 2 plus 1, so 3/4. So again, slightly, like this is 1/4 and then 1/2 and then 3/4. Like it's getting slightly steeper, but not by much. All right, what is Y for this whole row? 1. So that means your denominator is 2. Try to just hold that in your head. The denominator is 2. So for this one, you get -2 plus 1. So -1/2. So what was this one was -1/4, right? So -1/2 will be like slightly more steeply negative. This one is going to give you 0 plus 1 +1/2. So that just reflects over. I know. These are kind of like that. All right, this one would give you 1 plus 1 2/2, which is 1. That's the steepest one we've had yet. And then this one would be 3/2. So that's even steeper. And then we kind of do catch a break here because all of that is just gonna what? Reflect. Okay, so just, you know, I'm not here to grade your art skills, just do your best. And it looks kind of cool. Or whatever, good enough. Again, when you're doing these, each slope by itself, you're gonna be like, this doesn't look like anything. But then once you get the whole picture, it does kind of come together and sort of look like something. Now you won't know what these are because they took this material out of the Algebra 2 curriculum. It used to be in there, it's not in there anymore. What these are called hyperbolas. You know how we have parabola? These are hyperbolas. Did you do that in the ACA, man? Hyperbolas? No. Oh, okay. Well, they look like this,
Oh,
and that is considered one hyperbola. Like the whole thing. Oh, do you see the? And it can also go this way. Like it could be sideways or it could be like that. And then this is, this is considered the center. I always called it the belly button when I taught it. But do you see how you could have a hyperbola here? Like, or it could be the sideways one. Okay. So anyway, that's what they are. Hyperbolas with a center at -1, 0. Cool. I'm glad some of you saw that and knew what that was. We used to teach it. I have seen hyperbolas on there, but only in this context. You don't need to know anything about them besides that this is a hyperbola. And I've only ever seen them with slope field. Like, basically, no. If you understand what I just said to you, you're good. Okay. All right. How would you separate this one? Multiply the 2y. So 2y dy equals plus 1 dx. This one actually didn't end up being too bad to solve. So antiderivative for 2y. Y squared equals 1/2 x squared plus x plus c. Now you're going to square root, and what are you going to put in front of it for the general solution? Plus and good, perfect, because you want an infinite number of answers. Go ahead.
so it's not.
Correct, because and you'll see when we graph it, I'm going to explain this, but you already asked. The top half is the positive, and then that's the negative. So we're only going to get one of them for the particular solution. You basically get half a parabola or a hyperbola. Sorry. All right. So now we're going to go back to this step right here. Again, you can't jump to the end. It doesn't work like that. All right. So go back to that step. We're going to plug in -1 for x and +1 for y. So 1 squared is 1. If we plug in -1 for x, that's going to give us 1/2 - 1 plus c. Sort through that, what would c be? It would be 1, I think I heard somebody say 1.5, but I like 3/2 better, so I'm going to go with that. If you want to write 1.5, fine, that's a personal preference. So we're going to recopy that line, except put the 3/2 or 1.5, whatever you wanted for that. And when we square root, we're going to choose plus or minus because this is one particular answer, not an infinite number of them. And it comes from the output value. It's whatever the result is. So we want the positive square root. And then when you draw it in, you just start where they told you to and swim with the current. All right, so it's -1, 1. So right here, I'm going to start at -1, 1. And then you kind of just like, I'm going to look at mine, make sure I like, they're so picky about it, but it's just, you don't want to go through any of them. You just want to kind of like follow where they're telling you to go. It would kind of go something like that.
So, question.
Mhm.
So I do mine like above where you do it.
Like above there.
Yeah,
That's why I looked at mine real quick.
That goes.
They will mark it wrong. I know, like the messenger, I'm so sorry. Here's what I would do. Here's what I would do. And I'm going to let the recording go while I keep saying that, because here's what I would do. You have this, right? I would try to plug in one and see about what it comes out to and see if it would be above or below two. So like if you, and you don't need it to get it exactly, but just to like help you figure out where it would go if it seems like it could be one or the other. Okay, I'm gonna let you guys try that last one. It's a quick one. I saved an easy one for last. I'm gonna draw it while you guys are, can you knock out whole rows at once or whole columns? Columns, yeah.
Oh, wait a minute, that's.
And if you can draw it and describe it, honestly, I'm happy, because I know the seniors are gonna leave in 1 minute here, but you can draw, look how fast I drew. I mean, like, I understand I've been doing this forever, but you can knock out whole columns at once. And then I basically just want you to tell me what it is. What, if you were to follow along with those slopes, what kind of a graph do you get? Think about your parent functions, which one is it? If you follow these slopes,
I'm gonna say cubic.
cubic, good,
Oh, yeah.
good.